let's talk about atoms and molecules. These may be phrases that you've heard before. Let's describe some particular definitions of them so that we have the chemical context for how we're going to talk about them. Atoms we're going to think of as, it helps if my pen works, atoms we're going to think of like a ball. Now, they are a very, very, very small ball, and if we had taken, say, a large number of these, and we split them up, the atom would be what was left. So it is the particle that retains all the properties of the element that we're interested in. And if we were to split it up again, we would actually be doing nuclear chemistry. So we think of atoms as being the smallest particle that we have that still has all the characteristics of the element. So if I was talking about a different type of atom, then I might have a different color, or I might have a larger one or a smaller one. And you could see, oh, that these are different types. Now, different types of atoms would be different also types of elements. Now, it can be a little bit tricky here because an atom will always refer to an element, but an element will not necessarily always refer to an atom. So make sure that you've connected that atoms are always elements, but elements are not always atoms. Molecules are when we have two or more atoms that are chemically bonded together. So for example, this is going to act as one thing with different characteristics from the individual atoms that you started with. So for instance, we think about water, which has a formula of H2O and is essentially an oxygen atom with two hydrogen atoms chemically bonded to it. And to make water, we would have done a chemical reaction where we had some hydrogens and some oxygens reacting together. And notice that hydrogen is very flammable, and so is oxygen, but water is not. So we've made this new thing, we've made this molecule that contains oxygen and hydrogen, but it has its own new complete identity that's separate from the individual atoms that we started with. And it acts as a unit. So this water molecule acts as H2O. It does not act as some O and some H. It acts as this unit. So molecules can be described as homoatomic or heteroatomic. Homoatomic would be something like our hydrogen and our oxygen molecules here. Homo meaning same. So these are molecules with the same type of atom present. Heteroatomic would be like our water molecule here, where we have two or more different types of atoms present. Molecules, as you can see in our illustration here, can either exist as elements. For instance, here I have oxygen, which is just one type of atom, so these would be considered, let me make this a different color so it'll stand out a little bit. These would be considered elements. Only one type of atom is present. Versus water, there are two or more different types of elements present, so this is both a molecule and a compound. And there's another video that explores elements and compounds later, so you may run across that as well. So molecules, when we say molecule, we could mean element if we had a homoatomic molecule, or we could mean compound if we had a heteroatomic molecule. Compounds, this is convenient, compounds are generally, at this stage of the game, always considered to be molecules. So if you have a compound, you can say, oh, that must be a molecule, not an atom, because a compound has to be two or more atoms, two or more different types of atoms bonded together. All right, so back to our molecule discussion. They can be homoatomic, they can be heteroatomic, or we can describe them according to the number of atoms present in the molecule. So diatomic refers to 2 atoms present, triatomic is 3, and poly is 2 or more.